So I am going to record just a quick video, a short video, to show you a tool that is really interesting when working with digital systems. If you go to the practices tab in the virtual campus, you are going to find DITS. DITS is a free software that is going to be like a simulator of digital systems, so the equivalence of LTSpice from the topics of digital systems. So I recommend you to download DITS. I'm going to show you how to use DITS, just to check that the solution of the problem that you are doing are right or not. Imagine that you are analyzing a circuit, so you are going to obtain finally an algebraic functions that are going to have a Boolean, a truth table. So you can use here logic gates, and you can build the same circuit that in your exercise, and you can check the result, so you can compare the truth table of the result in DITS with the truth table that you have obtained in your exercise. Or for example, if we are designing a digital system, when we design a digital system, you know that the first step is to obtain the truth table of the system, and the last step is to build the logic circuit that corresponds to the truth table of the beginning of the exercise. So in order to check if the circuit that you have built from the minimal sum, for example, is that performed the truth table that you built in the beginning of the exercise, we can, for example, build here the minimal sum circuit. Remember that the minimal sum circuit has two levels of OR gate. So, for example, if we have a simple function with 3 product terms, we are going to have in the second level an OR gate with 3 inputs, and in the first level we are going to have 3 product terms. I'm going to consider, just for simplicity, that the product terms are formed by the product of 2 literals. So I can do this. And build the same circuit I have obtained in the exercise. So here, for example, I'm going to imagine that these variables are negated, and I have to add the input. The input are here. I can use, for example, a switch. This is going to be a switch that is going to be called X, another switch that I'm going to call Y. I'm going to consider that I have a 3-variable function and set. And now I connect in the same way as in the circuit. That, for example, can be this. I'm just inventing the connection, but you are going to use your real connections, the connection that you have got in the circuit. Sorry. So now I have my 2 levels, minimal sum and OR level. I have to add the output. So the output can be, for example, set. I have select output of 1 bit. If you have several outputs, just select several of these elements. Okay. I connect the output here, and now I can check what happens with the output when I change the values of the input. I press simulation start animation. You have to save the file before, and now you can press here and you can see that the output is going to change according to the input that you have here. So you can check the age combinations of the truth table and see what happens with the output. So you are going to have here a truth table that is, this is working. This is the right result. You have to compare this result with the truth table that you have in your exercise. This can be a little time consuming because you have to manually input all the combinations. You can use another resource. You can use clocks. I'm going to tell you how. If you just let me remove this. If you look at the combinations of the input, you can see that for the least significant variable, we have changed from one combination to the following: 0, 1, 0, 1, 0, 1. If we see the following variable, the change in the values is the double of slope of the previous variable. If we have that the variables are square signals, this is like this: 0, 1, 0, 1, 0, 1. And if we look at the most significant variable, we have that the period of changes is the double of the previous variable. So for x here, we have this. I don't know why this is not working. Sorry. So just using square signals with the appropriate periods, we can cover all the combinations of the input. And this is quite useful when you have a lot of combinations to check. So we are going to use this combination. Okay, so I'm going to select in the input a clock generator. A clock generator that is going to be the X, the Y, and the Z. And now I'm going to configure properly the periods. I'm going to click twice here and I'm going to select the period. For example, I'm going to select here 1 millisecond. 1 millisecond. If I have 1 millisecond for the Z, for the Y I need the double so I need 2 milliseconds. And for the X I need the double of the previous variable, so 4 milliseconds. Now I'm going to simulate using the timing diagram simulation. The first thing is my period is in the order of milliseconds, so I have to configure this scale with milliseconds, so I zoom out until I see milliseconds. Now I have all the possible variables of the input, and you can see the values here. This is x0, y0, z0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. If you see, we have all the combination of the truth table, and here they repeat again. So just looking at this, I can get the truth table. So I'm going to press play. So for this example, my truth table has in the output 0, 1, 1, 1, 0, 1, 0, 1. So this is a really fast way of having the truth table of your circuit. So I think that this is really simple and really useful when checking digital circuit. So use it when you are practicing with the exercise of topic 4 and 5. And that's all. If you have doubts, let me know. Thank you for watching.